Okay, so this is a lesson on rational exponents. So the first thing I'm going to show you is how do we convert a radical to a rational exponent. And I'm going to show you the thought process behind it and how it's created. And then at the end, I'll show you the shortcut, how to get there. So right here on the left, I have the square root of 4 equals 4k. Right now, I want to figure out what k is. So to solve this, I'm going to get rid of my square root by squaring. But what I do to one side of an equation, I must do to the other. Now the square root and the square can cancel out, leaving a 4. On the right side, I have 4k to the second power. Well, an exponent times raised to an exponent is multiplication. So what I end up with is 4 to k. Now on the left side, I can write 4 with an exponent of 1. So now I can use something called the powers property of exponents that allows me to ignore the 4's at the moment and just focus in on the exponents. From here, I can divide both sides by 2 to find out what k is. So k equals a 1/2. No decimals are allowed. So now I'm going to go back to the original problem. The square root of 4 equals 4, and now I know what the k is, a 1/2. It's trying to let you know that the square root of 4 is the same thing as saying 4 to the 1/2. Now I'm going to come back to this in a moment, but I want to do the problem on the right now. I'm going to go with the same approach. I want to get rid of the cube root this time. So to get rid of a cube root, I need to cube it. But what I do to one side, I must do to the other. From here, the cube root and the cube can cancel out, leaving only the 8 equals, once again, using the exponent raised to an exponent, which means multiplication, we can rewrite the problem like so. And once again, 8 really has an exponent of a 1. So now I can use the powers property to ignore the 8 and just look at the exponents. So here is where I would solve for k, divide both sides by 3. So I'll have k equals 1/3. So now I'm going to rewrite the problem once again from the beginning. The cube root of 8 is equal to 8 to the 1/3. Once again, trying to let you see that the cube root of 8 is the same thing as saying as 8 to the 1/3. But how can we do this without having to go through all these steps over and over and over again? Well, there's a faster way, and this is what it is: memorization. First thing you have to realize that a square root has a value right here. It's a 2. That is called the index. And that 4 inside the square root has an exponent. And therefore, if you look at 4 to the 1/2, you'll notice that the exponent from the radical is on top, and the index is on the bottom. You'll see the same thing with the cube root of 8 equals 8 to the 1/3. The 8 inside the cube root has an exponent. And the index of the radical is a 3. You'll notice that the top of the fraction is the exponent from the radical, and the index is on the bottom of the fraction. So we can quickly convert from radical to rational exponent by just memorizing the order in which it's set up in the fraction. So if we look at this problem, I want to rewrite a radical to a radical exponent. So number 1, I have to remember that the 4 really has a 1 as an exponent, so it's simply 4 1/3, exponent over the index. Same thing for number 2, 5 exponent of 3/4. And then the third one, 3 2/5. The exponent goes on top, the index goes on the bottom. And they have now been converted into radical form without having to do all that work that you saw previously. Now I can convert the rational exponent to a radical by using that same knowledge. The top number is the exponent and the bottom number is the index. So square root 2 to the third. Second one, the third root of 5 to the second. And then the bottom one, the fifth root of 7 to the fourth. Now, one thing about converting rational exponents to radicals and radicals to rational exponents, there's something that you can actually do. Here, there's two ways to write it. You could rewrite it as the square root of 2 in the entire radical raised to the third power. And same thing here. You could have the cube root 5 all raised to the second power. Or you can have the fifth root 7 raised to the fourth power. That will become helpful to you in future math classes. Sometimes it's easier to have the exponent inside the radical, and sometimes it's easier to have it outside the radical. It'll just depend on the situation. It's not something you really need to focus in on now, but it could be presented either way on the end of your course exam or on the 9-week exam. All right, to simplify an expression when you have a rational exponent. So what I'm going to do is I'm going to go over here and write parentheses to the 1/3. I want to rewrite my 64 as an exponent where it's some value raised to the third power. So therefore, the number would be 4 to the third is the same thing as saying 64. Well, what I'm going to do, I have an exponent raised to an exponent. I have 3 raised to the 1/3. I'm going to simplify that with multiplication. So I'm going to go off to the side here, and I'm going to have 3 times 1/3. Well, that 3 is really 3 over 1. 3 times 1 is 3. 1 times 3 is 3, which equals 1. So I really have 4 to the first power once I've multiplied the 3 and the 1/3. And well, now we have 4 to the first, which is simply 4. And you have simplified that expression. Well, you don't always need to go off to the side and go 3 times 1/3 to get the 1. There's a little bit of a faster method, and I'm now going to show that to you on the right side. Once again, I'm going to rewrite the problem, so I have parentheses 1/4. But now I got to figure out what number to an exponent of 4 gets me 16. Well, that's 2. 2 to the 4th is actually 16. No, there is no quick way to just know that. It's something you'll have to figure out with your calculator, and that's just trial and error till you figure it out. Okay, so the quick method is simply going, if this exponent is a 4 and the denominator of the rational exponent is 4, this can simply be canceled out, leaving 2 to the first, which is really 2. And you're probably looking at me like, Mr. Sika, how in the world can you do that? Well, this is the math behind it. 4 times 1/4 equals, remember, you can reduce fractions before you multiply them. 4 and 4 reduces, leaving 1 times 1, which is 1, 1 times 1, which is 1, which is 1. That's how I can get to the first so quickly, by just realizing that that 4 and that 1/4, those 4s can reduce out and just leave 2 to the first. Okay, so looking at this, using the same skill, but you're doing it twice, and then you're going to do some operation, whether it's subtraction, multiplication, division, addition. It really doesn't matter. Do each piece individually, and then just do that operation in the middle at the end. So I have 64 to the 1/6 power. Once again, I'm going to go ahead and rewrite it. So there's a parentheses to the 1/6 minus parentheses to the 1/2, dealing with the 64 first. Well, 2 to the 6th power is 64. Once again, knowing that these two would reduce out when I multiply those two values together would give me 2 to the first. Looking at 36, I need to figure out what number to the 2nd power gives me 36. 6 squared. Therefore, now this 2 and this 2 can cancel each other out, leaving 6 to the first. Well, 2 to the first is 2, 6 to the first is 6, 2 minus 6 is -4. So I've simplified that expression. I go with the same approach with the 100 to the 1/2 power times 64 to the 1/3 power. Parentheses 1/2 times parentheses 1/3. Well, 10 squared would give me 100. And once again, notice that the number in the denominator and the exponent here are always the same. I'm always trying to get them to be the same. If I don't get them to be the same, I can't do that really nice canceling out. And therefore, you've made this problem much harder. And I really just want you to figure out what number squared would get me the 100. So now the 2's can cancel out. So I have 10 to the first. And then what number to the 3rd power is going to get me 64? That would be 4 to the 3rd. Now the 3 can cancel out the 3, leaving 4 to the 1st. Well, 10 to the 1st is 10, 4 to the 1st is 4, 10 times 4 is 40, and I have reduced that expression. All right, simplifying the expression when you don't have a 1 in the numerator. You handle it just like you would the other problems. So we're going to have parentheses 3 to the 2nd, and once again the denominator is 2, so I want to figure out what number to the 2nd power gives me 25. Well, 2 squared gives me 25. Just like before, if these are the same, they can cancel out. And so now I'm left with 5 to the 3rd. Well, 5 to the 3rd is 125. It's not 15. Double check your calculations in your calculator. The other one, 16, 5 over 4, once again, set of parentheses, 5 over 4. You're going to ask yourself, what number to the 4th power is going to give me 16? That will be 2 to the 4th. And therefore, the 4 and the 4 can once again cancel each other out, leaving 2 to the 5th. And 2 to the 5th is 32. And that's simplifying an expression when your numerator is greater than 1. Well, what happens if you have variables? Same idea. Going to go step by step with you. First thing I want to do is set it up. So I have a set of parentheses for the 25, 3 over 2, and then times x squared to the 3 over 2. I basically used the distributive property with my exponent. So now I got to figure out what number squared gets me 25. 25 squared. Once again, the 2's can cancel out, leaving 5 to the 3rd. And the 2's can cancel out, leaving x to the 3rd. Well, 5 to the 3rd is 125. Nothing else happens to the x to the 3rd, and I have simplified the problem. All right, for the next one, same idea. It's a set of parentheses, 5 over 4 times x to the 8th, 5 over 4. And I want to figure out what number to the 4th power gives me 16. That'll be 2 to the 4th. Once again, the 4's can cancel out, leaving 2 to the 5th. Well, I have an 8 and a 4 this time. They can cancel. What is 8 divided by 4? 2. What's left is 2 times 5, which gives me x to the 10th. Well, 2 to the 5th is 32. Then I have my x to the 10th. And I have simplified an expression with variables.